Hello everyone, my name is Daryl. I work as a software developer, and in this video you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain myself as I work through it. My solution won't likely be the best or most efficient. It'll just be the one I kind of come up with first as I'm working through the problem. So this is another easy one. It's number 100 on the website, called Same Tree. So it looks like we're going to do another tree problem like we did last time. I wonder if this is the tree section of the problems. So this one is, given the root of two binary trees p and q, write a function to check if they're the same or not. Two binary trees are considered the same if they're structurally identical and the nodes have the same value. So these two would be the same, and it returns a Boolean. These two are not the same, and these two are also not the same. Number of nodes in both trees is between 0 and 100. Each value can be negative 10,000 to 10,000. Okay. So I just recorded the previous tree problem, the last video that I released. I think it was problem number 94 right before this. So we can do a similar way. The way I'm thinking about doing this problem is you could navigate to each node in the tree. And at each node, you're basically just trying to check that is this node set up the exact same way in both trees. And it's going to be kind of recursive in kind of the same way that we had the other problem. So let's go ahead and we'll copy over this tree node class once again. And then I can copy over solution class and we can get started on this one. We're going to create a function called, make it private, function are the same node. And this will take a tree node. This will be tree node 1. And then we'll have tree node 2. And we're going to have them be not nullable. In this function, we'll check. We need to handle the nulls real quick. So if p is null and q is null, then return true, because they're fine. And actually, let's instead of doing it like this, I want to do it like this, only because it makes handling the other case a little bit more simple here. So if they're both null, we can return true. Else we can return false. And, or you know, let's actually have it the way that we had it before. I'll leave it the way that was. That's fine. This is actually fine. We'll just do then if p is equal to null and q is not equal to null, return false. If p is not equal to null and q is equal to null, return false. Otherwise, we're just going to return, and this is going to return a Boolean. And it's just going to be returning are the same node for p and q. And we know at this point that they are not. We can force unwrap them because we know they're not null because we just did all those checks. And so now, remember with these tree problems, all we need to do, keep it simple, is just think about what we need to do with the exact node that we're at, and then the recursion will take care of everything else. So when you're at a node, we're just going to go ahead and do the exact same in-order traversal that we did before. So first we just check if the values are the same. If the values are not the same, rather. So if tree node 1.val is not equal to tree node 2.val, and return false. Now we check if the structure is the same. So we know the values are the same if we're here. So if tree node 1 dot left is null and tree node 2 dot left is not equal to null, return false. If tree node 1 dot left is not equal to null and tree node 2 dot left is null, return false. If tree node 1 dot right is equal to null and tree node 2 dot right is not equal to null, so right is equal to null for tree node 1 and not null for tree node 2, then return false. If tree node 1 dot right is not equal to null and tree node 2 is null, return false. And we want to do dot right. So these are kind of the checks. So this is checking if the values are the same. This is checking if the structure is the same, knowing that the value is the same at that point. So at this point, we've basically determined that at this current node that we're at, they're exactly the same. So now we want to go ahead and do the traversal. So if are the same node, if not are the same node, tree node 1 dot left and tree node 2 dot left, and we can force unwrap those because we already did the null checks, return false. And if the exact same thing, but checking the right side of both. So we've confirmed at this point in the code that they have the exact same value and the exact same structure. So now we just want to say do the exact same check in left node. We want to navigate down to the left one. Oh, and in this case, we do need to make sure that that's the case, though. If tree node 1 dot left is not equal to null, we obviously at this point know that if this is not null, then the tree node 2 is not null. And then same thing here for right. If tree node 1 dot right is not equal to null, then go ahead and do that. And then if you get all the way to this point, then return true, because we've confirmed that it's true. So essentially the way this is going to kind of work is it's going to keep going down the tree, and then if it ever finds a false, it'll end up returning that false up to the top immediately without checking the rest of it. Otherwise, it'll just keep continuing to traverse, and if every single step is exactly the same, then return true at the end. So let's copy this in to the solution here and give this a shot. So it worked with the first example. Let's do a submit. All right, and we got an answer, first try. It's not too often you get first try. Once you get used to doing these tree problems, they're really not that bad. So looking at this, I'm lower than average, again, on the runtime and memory usage, but not too horrible. There's probably a better way to do these checks than the way that I did it, but I think that's fine. So let's quickly go over the code. So first we're checking with this top node right here. Because we're going to be passing non-nullables to this are the same node function, we need to make sure that they're not null and go ahead and do the checks here. So we know that if they're both null, if these ones that are passed in here are both null, then they're the same. They're both null. So just go ahead and return true. If one's null and the other's not, then return false because they're not the same. Then just check the other way around. But if they're both not null, then we need to check if they're the same node. In this function, this is something we're doing at each node. we're going to first check, do they have the same value, both of the nodes? Otherwise, return false. Then you're going to check the structure. So once again, this is just checking the values. This code right here is checking, is the structure of the nodes the exact same? So it's checking kind of like we did up here. Do both of these have either they're both null on the left node or they're both not null? If that's not a true statement, if they differ, then return false. Same thing on the right. Are they both null or are they both not null? If they differ, then return false. And then if we passed all of that, then we just want to check further down the stream, and we're just doing this in order value. So we're going to just run this exact same function on the left nodes. And then once again, due to recursion, this will end up being run in order value through the entire tree. And if we get through this entire thing and we don't find any issues, so this is basically kind of the bubbling up false function, right? So let's say that we go 5 lefts down in a tree and it finds that one of these false. It's going to return false to the one to the top, which is immediately going to see that this is false. So it's going to return false to the top. So without even checking the rest of the tree, it's just going to be returning false straight up to the top, which will end up returning straight through here. Either that, or if we get all the way through here, then it's just going to return true. And then basically it's going to keep checking all the nodes. And if all of them end up being true, then it'll return true at the end. So I hope that helped you guys out. Thanks for watching. Catch you guys next time.